So as we have constructed this parsing table, you would have noticed there are so many blank spaces across this action section, which stands for more rigorous treatment of those reduction operation. So you cannot just like that keep on reducing for any item that you find, sorry, any terminal symbol that you find in the input. You will be selectively put it. So you are putting more stricter measures for the reduction operations. That is why you see this reducing operations very less. You have so many blank spaces. So let us consider the tracing of this particular string, that is id plus id for this particular grammar. So on the stack you have state 0. So input, let us consider it as id plus id and right hand marker dollar. So you have so what happens? 0 on id, what happens? 0 on id, you have a shift operation, so you do the shift 3. So what happens when you have a shift operation? The 3 has to be pushed onto the stack, so it is $003, and this id will be removed, so now it is plus id dollar, plus id dollar. So 3 on plus, what happens? 3 on plus, it is reduction using the third one, that is t gives id. Reduction using the third one, that is t gives id. So it is a reduction operation, reduce t gives id. So what is a reduction operation doing? So you have only one symbol on the right hand side, so that one state has to be removed. That is, you have to pop the state 3, that is the number of states which will be popped from the stack will be equal to the number of symbols on the right hand side of the reducing production. Okay, so you have one symbol here, so that one state will be removed, so pop 3, and you have now after popping 3 you have 0 there, so 0 on t you need to find out from the go to section. 0 comma t, so 0 comma t you have 2 there, so you get 2. That 2 has to be pushed, so you pop 3 and on 0 you need to push again 2, so that is 0 2. Okay, here it will be the same, there is no change, plus id and dollar. Okay, what happens on 2 on plus? 2 on plus, it is a shift operation, so you have shift 4, so which makes the stack $0 2 4, and here it is, the plus will be removed, you have id and dollar. 4 on id, it is again a shift operation, you have shift 3. Okay, so that means here you have 3 also pushed, so you have 3 here, and since it is a shift operation you have id removed, so now it is 3 on dollar, so 3 on dollar you have reducing using R3, that is R3 is, that is again the same production, that is t gives id, reduce using t gives id. So since it is one symbol you have to remove this 3 will be popped, then you get go to. So once 3 is removed you have 4 on top, so 4 comma the left hand side, that is t. 4 comma t is, you have 4 on t, you have 2, so again 2 will be pushed, on this, so 3 has to be removed and 2 is pushed, so that is $0 2 4 2. Okay, so Now here it is dollar. So 2 on dollar. 2 on dollar, it is reducing using the second production, that is E gives T. Okay, so reduce E gives T. So since it is one symbol on right side, 2 will be removed. So we have for 2. And what happens? You have 4 on top. So find the go to 4 comma E. 4 comma E is 4 on E, it is 5. So 5 has to be, after removing 2, popping 2, you have to push 5 to the stack. So that is $0, 2, 4, 5 and dollar. So 5 on dollar you have R1, that is reduction using the first production, that is E gives T plus E. So you have reduce E gives T plus E. Since you have on the right hand side you have 3 symbols, so 3 states has to be removed, that is you will remove pop, 5, then 4 and then 2. Now you have 0 on top, so which means go to, you have to find go to. After removing these 3 you have 0, so 0 comma the left hand side, that is E. 0 on E is 0 on E, it is 1. So after removing these 3 we need to push 1. I'll write it here, $0, 1. This one will be pushed. After removing 5, 4, 2, this one will be pushed. So 0, 1. And here it is dollar. So now it is 1 on dollar. 1 on dollar is accept. So this is the tracing of this particular string, that is ID plus ID, which is valid according to this particular parser. So we have now seen the canonical LR parsing technique. We have constructed the canonical LR1 collection. So I'll just go through it once again. So we have canonical LR parsing, otherwise called as CLR. It is an LR1 parser. So there is a one token of look ahead. This one stands for one token of look ahead. So instead of LR0 items as in SLR and LR0 parsers, you have LR1 items here. So LR1 item is a combination of LR0 item and the look ahead. So look ahead also will be considered. So for example, you have A gives alpha, which is any sequence of symbols, terminals and non-terminals, comma, sorry, dot B. So this is an item, LR1 item. B is a non-terminal, then comes beta, which is a combination of again terminals and non-terminals, and you have the second section which comes as the look ahead. Okay, so we have considered an example, that is example grammar is E gives T plus E, E gives T and T gives ID. You have augmented it, E dash gives E, and these 3 productions. And so this is the augmented grammar. You have numbered the original productions as 1, 2, 3. So while finding the closure, when you have to find the closure in this canonical LR1 collection that you are going to prepare here. So for the closure, you will have this LR1 item. A gives alpha dot B beta comma A. So this part is LR0 and this is the look ahead. So whenever you have this, after dot you get a non-terminal, so you add all those non-terminals on left hand side, all those productions with this non-terminal on left hand side with dot on the left end on the right side. So B gives dot gamma, which is again combination of terminals and non-terminals. The second section, how do you find this? That is, you are adding all those items with B on left side. So whatever remaining on the right hand side of this particular item, that is beta and A. So you get a combination of this beta A and get the first of this combination. First of beta A will be the look ahead for this particular newly added item as part of finding the closure. Okay, so we have found this. You have I0, I1, I2, I3, I4, and I5. You have five. You have sorry. You have six states, and you have constructed this DFA, which is the canonical collection of LR1 items. And from this, you have constructed the parsing table. So you have 0, 1, 2, 3, 4, 5. You have these many states and shift operations and the go to section. All the shift operations under this action as well as all the go to section indicating these states are exactly the same as compared to LR0 and SLR. The only difference is with LR0 and SLR1 is that one thing is you have LR1 items, and the second thing is you are indicating this reduction operation only for those look aheads that you see here. So since you have, for suppose for I3 you have plus and dollar for this, so you consider that particular production, and that will be added, that will be indicated only against plus and dollar. If you remember, in SLR1 you have considered the follow of that particular non-terminal that you are on the left hand side of the production that you are considering for reduction. Okay, so there it was follow, here it is this look ahead. So this is actually considered to be more stricter compared to SLR and LR0. Okay, so you have those reduction operations here, and you have traced for this particular string, that is ID plus ID. So these are the steps. Actually tracing and all, everything is exactly the same. Since you have this parsing table, this portion it is repetitive. Actually it is the same as whatever you have seen for the other parsing techniques. Okay, the only thing you need to keep in mind is that you need to have this canonical LR1 collection of items, and you will be adding the reduction operations only against the look aheads that you get in this canonical LR1 collection of LR1 items. Okay, so this is the CLR canonical LR parsing technique.